Let's start with the first law of thermodynamics. Here are three qualitative statements of the first law of thermodynamics. Let's look at the first one. The energy of the universe is constant. That's a statement of the first law of thermodynamics. Let's go back to the previous lecture where we defined the universe as a big box. And here's the universe. And within the universe, the energy is constant. That's the statement of the first law of thermodynamics. Within this statement, we're assuming that the universe is a closed system. In other words, what we're saying is that there can be no energy flow back and forth between them. Well, that sort of makes sense. If the universe is everything we know, then where's this energy going to or coming from? So that's a pretty good assumption. The universe is a closed system. There's no energy going in and out of it. So within this universe, energy is a constant. Now, when the universe was created, however it was created with a constant amount of energy. That's all it has, and as time went on and the universe evolved, here we are at present time. The universe has the same energy now as it did at the very beginning of the universe. The energy of the universe is a constant, and that's the first law of thermodynamics. One statement of it. Here's another statement. The energy of an isolated system is constant. And what's an isolated system? There are no energy flows between the system and surroundings. So that's what we said here. The universe is an isolated system. It's a closed system, but we can also say it's an isolated system. So an isolated system, no energy flow. So let's draw another universe down here. Actually, it's the same universe. There's presumably only one universe. And within that, we're going to draw, as we said in the lecture before, a system here. And we said that the part of the universe, so this is the universe, the part of the universe that's not the system is the surroundings. Energy can flow from the system to surroundings. The total energy within the system plus surroundings has to be constant. So if you take a certain amount of energy from the system and put in the surroundings gain just as much energy as the system had. All right, so now here's yet a third universe, same universe as before. And what we're going to do here is to draw our system within the universe, and this would be an isolated system. So isolated system, we said energy cannot flow between the system and the surroundings, and this is the universe. So since energy cannot flow, if you look at this isolated system, this sort of mini universe in here, we say that the change in energy of the isolated system has to equal 0. So that's what we mean when we say that the energy of an isolated system is a constant. So not only is the universe an isolated, but if we carve out a particular part of the universe and make it isolated, insulated, so no heat can flow, make it rigid, and all that stuff, then no energy flow between the systems and surroundings, then the energy of that isolated system is a constant. And then a third statement of the first law of thermodynamics is energy is not created nor destroyed. Energy, however, can be changed from one form to another, and we'll see on the next slide here what two major energy forms are. Or energy can be moved from one place to another. All right, so I hope you have a pretty good qualitative understanding of the first law of thermodynamics.